In this lesson, we're going to put everything that we've learned together and build a quick and dirty property valuation tool for Boston using our existing dataset. And this means that we're going to apply all the concepts that we've discussed previously, but also it gives us a chance to expand our knowledge of Python programming techniques. In fact, we're going to package our Boston property valuation tool as a Python module that you can then import into any other notebook, just as we've been importing, say, Pandas or Numpy. And also, we're going to cover how to write Python functions that have default values for arguments. And we're going to cover how we can include helpful documentation in our Python code as well. So how will this tool work? How will it find a price for a property? Well, it will make use of our existing model. Here we get the theta values from our regression, and then all we need to do is plug in custom values for all the features like RM, NOx, LSTAT, Chaz, and so on. And once we've done that, we have our y-hat for a property that is not in the dataset. So that's pretty simple, right? Now, of course, there are certain limitations with the dataset that we've been using, and we're going to have to work around these limitations. For starters, we don't have a column with the location of the homes to assist us in pricing homes depending on an area. And also, if you are searching for properties online, you're not going to be able to input some pieces of information that are just very, very abstract. Like, nobody's really going to know what the correct value for LSTAT is in the area that they're looking to buy a home in, or what the proportion of non-retail business acres are, which was the Indus feature in our model. In other words, we'll be working around these limitations, and also we'll be making some generous assumptions. But it's all in good fun, and we can learn a few things while doing this as well. So let's get started writing some code in Jupyter Notebook. Let's create a new Python 3 notebook to hold our code for our valuation tool. I'm going to call this notebook 04 valuation tool. And then I'm going to get started with our import statements. So we're going to need a couple of things. We're going to need from sklearn.datasets import load underscore Boston. We're going to need our scikit-learn's regression capability. So that's from sklearn.linear underscore model import linear regression from sklearn.metrics import mean underscore squared underscore error. And then we're going to import Pandas as PD, and we're going to import Numpy as NP. These are all the import statements that we need for now. Let me hit Shift Enter. Now I'm going to add a comment in the next cell, and it's going to read gather data. It's time to create our target and our features. If you recall, we can grab our dataset by calling the load Boston function. I'm going to store our dataset in a variable called Boston underscore dataset, and that's going to be equal to the return value from load underscore Boston. Now let me create a data frame. I'm going to say data is equal to pd dot data frame, and in the parentheses I'm going to set the data of this data frame equal to Boston underscore dataset dot data. This, if you recall, is not a data frame, which is why we're extracting the pieces of information that we need, namely our features data, by using that data attribute on the Boston dataset object. Our data frame should also have some columns, and these columns have names. So columns is going to be equal to Boston underscore dataset dot feature underscore names. I think this is all a little bit of review, but we're just going to convert our data into a format that we need. So how does our data frame look like at the moment? Data.head will show us the first 5 rows. So that's fair enough. We've got a data frame with all the features, but we're only going to use a subset of them. So features is going to be equal to a new data frame. So it's going to be data.drop. And then in the parentheses, going to have a list of things we want to drop. We want to drop indus and we want to drop age. Both of these are columns. So I'm going to say axis is equal to 1. Let's take a look at what the first 5 rows of our features dataset looks like. We should be missing this column here, and we should be missing this column here. Features.head will show us just that. Brilliant. This is what we've had before. Now let me delete this line and work out our prices. We're going to be working with log prices. So I'll create a variable called log_prices, set that equal to np.log Boston_dataset.target. Let's take a look at what this variable looks like. So log_prices is an array with 506 rows. We can see this by saying log_prices.shape. This confirms that we indeed have an array with 506 rows. But this array is flat. It's just one-dimensional. In contrast, the shape of our features data frame is 506 by 11. So I'm planning to work with prices that are two-dimensional. So 506 by 1. I'm going to get there by converting our log prices into a data frame. So I'll say target is equal to pd pandas dot data frame parentheses log_prices comma columns is equal to square brackets single quotes price all caps. There we go. Now if I say target dot shape, let's see what we get. 506 by 1. Perfect. Now, as we've said in the introduction, if we want to get an estimate for the value of a property, we basically have to create something that looks like another row of data, something that's structured exactly the way the features data frame is structured. So 1 row and 11 columns with a value for each column. How could we do this? Well, say we create a variable called property_stats, set that equal to an empty ndarray from Numpy, so np.ndarray, and we want that array to be 1 row by 11 columns. So we'll say shape is equal to parentheses 1 comma 11. Okay, so now we have an empty array. Now what we can do is give a value for every single column. So we can write something like property_stats and then access the very first column. So that'll be in row number 0, so the first row, and the first column, column number 0. So square brackets 0, square brackets 0. And I can set that to a very particular value. So I can set that to say 0.02. This is now my crime per capita. Let's see what this looks like. Property_stats, shift enter, will now show us something like this. This is scientific notation, yeah? So 0.02 will be 2 to the power of 10 to the minus 2. And these other values are 10 to the power of minus 314. This looks really strange, but what you're looking at is pretty much equal to 0. If I change this value here to say 83 and hit shift enter, then you'll see the array displayed like that. You have 83 and then 0, 0, 0, 0, 0, 0, right? So I know this might seem confusing, but before we were looking at the output in scientific notation, and here we're looking at it more normally. Now, a reasonable thing to ask is, how do you know that this very first column here is the crime column. Yeah, so this value here, how do I know that this should be around 0.02? Yeah, well, the answer is that our property stats variable, our 1 by 11 array, will have the same structure as our features data frame. So features.head, if you recall, will show us that the first column is crime, the second column are the zones, the third column is the Charles River dummy variable. So one thing that we might do, right? One thing that we might find helpful is if we give these different indices a name. So if we want to set the value of our second column and our third column, we could do it like this. I could copy this, paste it twice, change the second 0 here in property stats to 1. This would now be the zone. And if I want the zone to be equal to, say, 15, then I can do it like this. And if I want the Charles River dummy variable to be equal to, say, 1, then I would have to pick index 2 and set that equal to 1. You get the idea, right? So property stats now looks like so. We've got crime, we've got our ZN feature, and we have our Charles River dummy variable. Now, personally, I find accessing these indices by number very, very confusing because I'm going to come back in a week's time and I'm not going to remember that crime is at 0 or ZN is at 1 and Charles River is at 2. I only know that because I've worked with this data set and I'm looking at my features data frame below. So one thing that might be quite handy is if we give these numbers names, right? So I can come up here and say crime underscore index, IDX, is equal to 0. And I can say ZN underscore IDX is equal to 1. And Chaz underscore IDX is equal to 2. And so on. Now I can come in here, and instead of having a 0 there, I'll say crime underscore IDX. And instead of having a 1 here, I'll say ZN underscore IDX. And so on, right? Chaz underscore IDX. In other words, this is a technique for giving certain hard values a descriptive name. That way, when you're using them in your code later on, it's a little more clear, a little easier to read. Since we're not really going to change these values here, I've written them in all caps and separated them with an underscore. Now, I'm going to add 2 more named indices here. The first one is going to be for the number of rooms, so RM IDX, and that's in row number 4. And the next one is PT ratio underscore IDX, and that's in row number 8. Scrolling down, you can verify this. 0, 1, 2, 3, 4 RM, 5, 6, 7, 8 for PT ratio. Brilliant. Now, remember how this property stats array is empty at the moment. It's got zeros for all of these values, and it's got 3 of these values defined. Now, to be honest, we're not going to be customizing all these values, right? Because something like crime per capita is quite hard to know, or the acres of industrial land in a particular area is also really hard to know. We're going to make some assumptions. In other words, for the property that we're looking at, we're just going to go with the average for all of Boston, for now at least. To get the average, we can simply grab it from our features data frame. So features, square brackets, CRIM, in single quotes, dot mean will give us the average. And I can, of course, take this. I can do the same thing for our zones. So ZN.mean. And I could do the same thing for Charles River, Chaz.mean. And I could do the same thing for all the other 11 features. Now, what would this look like at the moment? If I refresh, I can see this is the average crime per capita. This is the average value for the ZN index. And this is the average value for Charles River. I'm going to stop copy pasting code and making this super repetitive. Instead, I'm going to grab the mean value for all the features at the same time. Check it out. Features.mean, parentheses, will give me all the mean values, all the average values for all the features. My goal is to populate our property stats with all these values. Our property stats is an ND array at the moment. But what is this? Let's take a look at what this is. Type, parentheses, features.mean shows us that this is a series. It's a different kind of object. So we have to do a little bit of conversion here. We have to make the series object play nice with our array. So features.mean gives us a series, but the series object has an attribute called values. So if I copy this, paste it in, and show you what this type is by adding dot values at the end, we can see that the values attribute on a series will give us an ND array. So array and array. The two things should play nice because they're the same type of object. But remember how this is a 1 by 11 array? Let's double check what the dimensions are of this array here. Features.mean.values.shape will tell us exactly that. This thing here, it turns out, is completely flat. It's a one-dimensional array. Unlike our property stats array, it is not two-dimensional. It means that we have to reshape this array from a flat array with 11 values to a 1 by 11 array. The easiest way to do this is to call the reshape method. So features.mean.values.reshape, parentheses, 1, 11 will give us exactly what it is we're looking for. Check it out. Brilliant. So I'm going to take this here and I'm going to say property stats equal to features.mean.values.reshape 1 by 11. And this means I do not have to do any of this. I can comment out all of these lines of code and save us all of this work, because we now have a property with some starting characteristics, right? So we have a property, a single row, 11 features, they all have a value, and in this case, the value is just the average of all the 506 properties in the dataset. In other words, property stats is kind of our template for making our prediction. This is the object that we're going to be working with.